This is Module 1, Lesson 3, and we're going to look at significant figures, which I call sig figs. You might hear people refer to them as significant digits or sig digs, but I was taught sig figs, and it's how I say them, so on we go with sig figs. What is a sig fig, you're probably asking. It's probably one of the most grumbled about things in chemistry. Here's your definition. It's all of the digits that you know for certain and the last digit that is guessed in a number. And if I can give you a couple of examples of what I mean by this, measurements are really important in science. So if we have a ruler here and we are measuring this red line, obviously this is not to scale. The purpose of this is just to understand what I mean by a sig fig. If we measure this red line, what we know for sure, we know for certain that this red line goes past this 1. It goes past 1 centimeter. We know for sure that it's less than 2. And then if we count these little bitty tick marks, these are, tenths of a centimeter if we're going to do this in centimeters, or they're individual millimeters if we're going to go in millimeters. We're going to go in centimeters. So this is 1, 2, 3, 4, 5, 6. I know for sure that that line, I do that every time, that line right there is between, dadgummit, that line is between the 6th and the 7th spot. Like, for certain, I know that it falls between that. Somehow I gotta figure out what I'm doing here, because this is gonna like drive us crazy. Right there. It's between the 6th and the 7th. So we know for sure that it is 1 centimeter. We know for sure that those stand for tenths. So it is somewhere between 6 and 7 tenths. Well, here's the thing. We need to guess the last one. It says the last digit is estimated. What we don't want to do is write down on our papers that that measurement is 1.6 or 1.7, because really we know it's in between. What would be a better answer is to put 1.6, we know it's at least that much, and then you guess the last digit. So maybe 1.66, you could say 1.67, somebody else might say 1.65. That's the whole thing, is the last one is estimated. It's a little bit up to you. Okay, the same thing could go with this one right here. Like if we look at our graduated cylinder, if we read it, what we know for certain, that it's more than 30. We're just going to assume that this is in milliliters. So we know for certain that it's 30 milliliters, and that means all these little ones would be 1. So that's 1, 2, 3, 4, 5, 6, 7. So it would appear to me that it is for sure 37 milliliters, but it looks to me like it's exactly 37 milliliters. So what we would do to estimate a digit is we would put a 0.0. And this is where it seems kind of funny compared to math class, because, I mean, the meaning is the same. It's 37. It has the value of 37 either way. But the difference between the two numbers is this one with the 0.0 tells me I know the 3, I know the 7, and the last digit was guessed. I guessed the 0. If I write it this way, that means I guessed the 7. And the last thing that I was certain about was the 30, was the 3 in the tens place, but that's not true. I guessed that it was exactly 37. It might actually be 37.1. It could be 36.9. What I'm guessing, though, is the tenths place. That is what is meant by a significant figure. Now, the good news is we're not usually going to be doing the measurements for class. Like most of the time we get numbers given to us and then we have to do calculations. And we're going to have some rules about how to round our numbers, but before we do that, we need to be able to look at a number and tell how many sig figs there are. So I have some rules for you. And this is the Houston version of the rules. This is my made-up way, kind of. I've adapted textbooks and other people's ways. The first rule is that anything that's not a 0, all numbers 1 through 9, automatically significant. So if we look at this number right here, if we look at 24.7, then we would look at it and we would be able to say that this has 3 sig figs. That totally did not change colors, did it? Y'all are going to be loving my inability to do stuff on here. Maybe we try blue. Oh, look, there. That has 3 sig figs. How do I know? None of them are zeros. This one right here, I'm counting everything that's not a zero. That's 1, 2, 3, 4. That has 4 sig figs. This one, that's not a zero, that's not a zero, that's not a zero. So that last one, it's a zero. So I only count the ones that aren't. That one has 3 sig figs. All right, pretty simple. Don't count zeros. So that leads us to really deal with the zeros for the rest of this, because the bottom line is sometimes zeros count and sometimes zeros don't. How do you know? Well, sandwich zeros. Sandwich zeros are significant. What I mean by sandwich is they're stuck in between two other things. We've already established in the first rule that 7 is significant and 3 is significant because they're not zeros. Well, if we know both of those, that means we have to know for sure the stuff that's in the middle. So sandwich zeros, they count. That is 4 sig figs. This zero, it's sandwiched between a 4 and a 7. I mean, the 9's on there too, but what that means to me is I count everything. 4 sig figs. This one, that zero, it's sandwiched, so I count them all. That's 4 sig figs. All right, these two zeros are sandwiched between the 8 and the 2, and these two zeros are sandwiched between the 8 and the 5. I'm hating this pop-up box. Okay, what that means is everything is significant. So count them. That's 3, 6, 7 digits. All 7 of them are significant. What about this one? There aren't any sandwich zeros. There's 3 zeros on it, but there's a 2 and a 4. There's no digits over here to sandwich them. So this one only has 2. We could go back up and look at this one as well. That 0 is not sandwiched. It is not, there's nothing over here on this side to box it in. This 0 is not sandwiched. None of the zeros on these top ones count. What about zeros that, sometimes are some maybe other special circumstances? Would be in numbers that are less than 1 and numbers that are greater than 1. The easiest way for me to tell you is this. If you have a number that is less than 1, you start counting from the first non-zero and count, stupid box, count all the way to the right side of the number. So if we start at the 7, then that's a 7 and a 1. That has 2 sig figs. All right, what about this one? Start from the first non-zero. Y'all, seriously, this is bad. Start from the first non-zero and count all the way to the right. That's 2 sig figs. What about this one? If I start from the first non-zero, there's only one of them. This one has 1 sig fig. Here's the first non-zero. Our rule is go all the way to the right. So if I go all the way to the right, that means that 0 is going to be significant, because we're just counting everything. The rule with numbers that are less than 1 is to count from the first non-zero, go all the way to the end. This rule is simply helping us deal with this 0 right here. If you stop and think about it, this first 0, it's necessary, because if it wasn't there, then this 1 would be in the 10th place. You've got place values. If we take out this first 0, then that would move the 1 over here to the 10th place, and it changes the meaning of it. It has to be there for meaning. But this 0 that's on the end, it doesn't need to be there. If I take it off, it's still the same value. The only reason for giving that final 0 is for significance. It's to tell you that I estimated. It's like our 37.0 from earlier. The only reason for giving that 0 is because it's of significance. So that last one counts. This one has 2. What about this one? Well, this one's sandwiched, but I don't even need to think about that. If it's less than 1, you start counting from the first non-zero and go all the way to the end. That has 3. This one, same thing. I see some sandwich zeros, but that's not what my mind goes to. I think find the first non-zero and count all the way to the end. That is 1, 2, 3, 4, 5, 6. 6 sig figs. Now, if it's greater than 1, you just follow all the rules that we've done before. So this one, it's got a 3. Those zeros are not sandwiched. It's not a number that's less than 1, so it just has 1. 7,000, that one counts as a sig fig. Those are not sandwiched zeros. It has 1 sig fig. This one, I did not mean to put a parenthesis at the end of it, so oops. all 4 of those are significant. This one, however, is not sandwiched, so it just has 4 sig figs. Now, I can make your life super easy. If you have a number that's greater than 1 with a decimal place, then they're all sig figs. There is no need to stop and think about anything. This one, greater than 1, got a decimal place, count all the digits. Got 2 digits, 2 sig figs. This one, greater than 1, got a decimal place. It's got 4 digits, it's got 4 sig figs. This one, it's greater than 1. It does have a decimal, and this is kind of weird, but this is one of the ways that we can make that 0 become significant, and we'll talk about this when we start talking about rounding in just a minute. Then that makes all of those count. What that does in essence is makes that last 0 significant. So that has 3 sig figs. This one right here, greater than 1 with the decimal place, count them all. That's 8. Now at this point, I'm betting that you guys are probably going, what about this? It's what usually happens in class. So if you have a particular number that you are curious about, you can either send it to me with like the Q&A part of this module, you could email it to me, and I can answer those questions for you. Some people catch on to this super duper fast, and some people take a little while. Another rule for this is that exact quantities have an unlimited number of sig figs. And I know that sounds kind of crazy, but basically they have an infinite amount. So if there are 23 people in a room, there is no uncertainty about that. You're not going to have a portion of one. How many sig figs are in this? Infinity. The fact that 60 minutes is 1 hour, there's no uncertainty about that. Like, we know this for sure. Both of those have an infinite number of sig figs. The same thing goes for like the idea that a meter equals 100 centimeters. Both of those have an infinite number of sig figs because it's a known, understood, defined quantity. Now, when we get to practice time, I'll use this screen for the last couple of little things that are different. I told you about the decimal on the end. So like, for example, if you have the number 200 and it has a bar over the middle one, like this, that little bar is a way of showing significance. What that means is that the 2 is significant and that 0 right there is also significant. I don't know where it just went. It's like magic. So this one would have 2 sig figs. I use SF to represent sig figs. This one has 2 sig figs because that bar is a way of indicating that the middle one is significant. Another way to write that with 2 sig figs is to write it in scientific notation. 2.0 times 10 to the second also has 2 sig figs. Basically what you do is you just forget about this part being there and you only focus on the 2.0. That has a sig fig. That is a sig fig because it's a number that's greater than 1 with a decimal place. So it's 2 sig figs. It's just easier to put the bar over the top. What if you wanted to write 300 with 3 sig figs? Well, you put a decimal there because that automatically makes both of those count. That has 3 sig figs. Or you could do 3.00 times 10 to the second. That would make both of those become significant because you only look at this first part. What you don't usually do is put the bar over the last one. Usually, if that's the case, you would just put a decimal on the end of it instead of doing the bar over the top. Okay, so what I have is some practice problems for you to work with trying to identify the number of sig figs. Keep in mind with scientific notation, you don't look at the times 10 to the exponent part. If you see a decimal on the end of a whole number, then that makes those zeros count on the end. And if you see a bar, that makes the 0 that it's over count. And I guess as I say that, I also think of what if it's something like this? What if it's 2,000 with a bar over the last one? What that means is that 0 is significant, the middle 0 is now sandwiched, and that 0 is significant as well. So if it's in a random place, you start counting from that 0 over to whatever else sandwiches it. Send me your questions. I know you're going to have them.